Hello, welcome to the demonstration of Windows internal WinDbg section. On the screen, I already share out my slide talking about from user mode to kernel mode. Usually, in the user process, such as Notepad, will come across when you call the Notepad to read a file or write a file, the user process will call some API in the system library, such as kernel32DLL, and then later on it will go into the ntdll.dll, which is the native API. And through the native API, the process control will pass to the kernel mode and some kernel data structure inside the kernel. Basically, what we're talking about the kernel memory will keep on running. The actual code of the create file and read file will passing through from top to the bottom until it hit the kernel running drivers. So subsystem library DLL basically is the what we mentioned in the lecture. Kernel32 DLL is one of them. And then the user process, for example, Notepad want to call the kernel32 DLL.dll, try to read the file. On the screenshot, you'll see I'm using the ID poll to show you, I'm using the PID to show you the content. What is the ordinal number, what is the RVA and offset of the API function called read file. The subsystem library will then call into the native API, that is ntdll.dll, which is, you'll find that facing the user mode area, one similar read file starting with the nt as prefix. So it will call that function. And then ntdll.dll will switch to the kernel mode through two of major functions. One is the sysinternal, one is the sysenter, another is the Internet 2E in the older version of Windows. So executive will then call the device driver, and then device driver will call the HAL, which is the hardware abstraction layer, to start reading the file from the hard drive. Here you will see that if I want to see something inside the kernel, I will type examine ntdll.dll is the native API name with the exclamation mark. I try to use the wildcard character to find this file, and now I will switching to the virtual machine so that you can check it by your own self according to what I'm presenting in this video. Now you can see my virtual machine. Before that, I need to make sure, because my virtual machine to have two network cards. One is pointing to the internal network of the host machine. I'm using VM Fusion. Another network card is pointing to the internet. So before I can use the WinDbg effectively, I need to make sure I can connect to the internet, because WinDbg needs to accessing the simple file hosted by Microsoft. So I try to ping Google, see whether it is accessible to the internet. So I don't need this command prompt anymore. Then I start the WinDbg, and then I kickstart the kernel debugging, local kernel debugging. So you will see I can start the WinDbg. So before I can do anything, try to examine things, I try to display the data structure of the memory inside the kernel. I need to do one thing, make sure it will reload all the symbols. So if we go to the internet, if you find this kind of information, that means your WinDbg has ability to connect the internet. Now I try to do the things that I presented in the slide. So the meaning of X is examine. Oh, if you want to know more about how to use the WinDbg, you need to go to help and then you can open it. Then you can, yeah, you can see expanding it and you can see a lot of options. You can making use of this uh, by your own self. But basically, I just try to go using the debugger window command, something like that. So I try to examine, X is examine, the ntdll.dll is the function or library name. Inside there's a function called with file, but I don't know what is the nt or zw or some other with file inside. So I try to use a wildcard character to show it. Okay, here you will find zw with file and nt with file. Nt with file is facing the user mode. ZW with file is facing the kernel, and it will have the same memory address. Okay, you still see some others. That is not our concern. We are not going to discuss that part. Then if we want to see what is the content of the function of disassemble the NT with file, I need to use the one of the WinDbg command called UF. UF means unfunction. Unfunction of ntdll exclamation mark nt read file. So now I can type the full name without wildcard character. Here you will see that the first instruction is lies in the address of, forgive me, I will not mention anything behind the 32-bit situation. In this example, I will regard the offset address of the function is located of AFBC0080, which is in the user mode. So one of the function move the RCX register to R10 register. Then we go to moving a number called 6. 6 is hexadecimal to the EAX register, going back to the 32-bit environment, and then do a test. If the test is something like this, in the test the pointer of the kernel user data, K user share data. That means that is a chunk of data residing in the user mode, but these content will continuously update and share out by the kernel. So we call it K user share data. With the offset from here and then pointing to 308. From here, you can guess that if we remove this part with the 7FFE, 0000 means the share user data location. And if not jump, it will go to the syscall function and then return back to the caller function, which is the caller function from the system library. And if that is equal to 0, if not equal to jump not equal, with this value, it will go to internet int2e, it means the hexadecimal. Then what if we try to see ZW? You remember that we typed the ZW? Actually, they are the same because they are same memory location. So that part is facing the kernel mode memory. Okay, let us go back to our slide. Okay, we using dependency walker to find out the ntdl.dl. We check that is 2 functions inside this location with the same entry point. 71F8, but this is not read file. This is create file. This is different. But the same logic, that is they have the NT version of the create file and ZW creation version of create file. Now we are visiting another slide that we already demoed the WinDbg inside our virtual machine. The same thing, but this time we are changing from read file to create file. You can practice this at home. Then those highlight is the function that we type called UF and function ntdl.dl libraries. One of the functions inside the API that is set the view grade file. It will show the information similar like the previous one of read file, but only exception is the number that to remove the EAX register before it passed to the kernel. That is 55 for the case of create file, and then go to the once if that is the case, the jump not equal to 0, then it will go to internet int to E. So if we want to check the kernel user data, we call it K user data. Then we take away this and then try to find whether it works or not work. Okay, so we go back to the virtual machine. Okay, we go back to our virtual machine and then we try to display type of my DT means display type of K user shared data without the memory address. It's wrong. It must something wrong inside the slide. Let me try something like this. For example, if I type ntdl, specify the library location. Okay, it doesn't work. Okay, so it should be kernel USEL. It doesn't work. So with the ntdl, let me try to reload. Okay, it doesn't work. There is another command called bang K user data. Let me check this first. Exclamation mark K user. It will show me the share data at this address 78 whatever, and then come into you find the system root of the Windows command. Let me try see whether I can make it show to you. ntdl exclamation mark K user share the data. Nope. Okay, so it must be something wrong in previously. But anyway, I can show display the K user data with underscore and put also ntdl.dl exclamation mark in front of this command. The slide is incorrect. And you can see only the structure. You don't have the data to be displayed unless you specify the offset address. So let me try the offset address of 7FFE. Now let me check whether we can find the system root. The system root should be lies in the 0v0. It doesn't work. How about I start the kernel location should be 7e something. It must be not correct. 7FFE is not correct. should rely on the location of the bang or exclamation mark uh, location. Yeah, should be, oh, it must be on this location. I think everything is okay, but I may overload. So display type would be F7FFE000, and you can find the anti-system with the information of the Windows. So the demonstration can show you, we can find out uh, the function name, and also we can find out what's the content of the K user space that located in the user mode. Now we go back to the slide. Now let us to the another topic is the system surface description table, in short name that is SSDT. First of all, we try to display, try to find out the full number of the description table in the kernel, and then we need to check the descriptive table content. There's four of them, and then we go to check whether we can find the number of the function contained inside the mtdll.dll inside the kernel, and also how many functions can be referred by the SSDT. And based on SSDT, we show the content of more object address that is to be located in the exact function inside the kernel function to be the actual code of the, for example, in create file, it will go to that location. So we go back to the virtual machine. Okay, let us go to the kernel, check the information. We type the DPAS display, can't remember PS, you can go to the help key to find what is DPS. For example, I go here, what's DPS, you will understand, well, this display something right here, display word and symbol, okay? So it must be some difference between DDS, DPS, DQS, but it is not my intention to tell you how to understand all the command in the WinDbg. You just use it to find out, to allow you to pick inside to the kernel. So we type NT K surface description of descriptor table. L4 means list for entry. This must be typing of DPS, NT exclamation mark, D the K surface description surface CE descriptor table L4. Cannot resolve it, try reload it. Let me try again. DPS NT exclamation mark K E SERVICEDEF RIPTIO table L4. Yeah, sometimes typo are affecting. So, because last time I forgot to type the KE means the kernel. So we can see two kernel description table. Now, how about we try to find description table instead of I want to see the description table's data structure. So I DT type displayed it, display the type NT with wildcard character descriptor table wildcard, and then show variables. Okay, we find actually the kernel the kernel DLL should in my virtual machine the original function name of the kernel module is called NTKLNLMP. If you do a search, you will find 4 different versions because of different architecture used by this kernel. But I let you to do your research. I am going to check what is the NT K surface table L4 to display how many function referred by these SFDT. So I go back to DPS again, and then NT exclamation mark, and then type the KE surface descriptor table L4. Oh, again wrong. Now, how about we save the time and copy and paste this one here. You will find 1D0. This is the number of how many function will reside in the SSDT of each version of Windows. We are using Windows 10, so if you want to see how many number of functions contained inside the SSDT, then you can try to type formats and then 1D0. It come out with 464 entry of SSDT. Each SSDT do have a pointer. The pointer will point to the actual address of that function code. So now next one is try to check the first entry of this 464 function. So I use the DT and using C1 K surface table. This time not 4. I want to see 8 entry. Now I do have the first entry of the function. What is the function? What's the function name? Maybe I can check it because each of the symbol table should contain this information. So let me try to do an assembly, which is showing the surface table plus this address. Sorry, I need to use 029 something. I forgot to copy and paste this one. And then I do a pointing the 4. Then you will see the first function is called NT-except connect port. And then if we move one by one, maybe we can find some other interesting information, and that is the location of the actual function, which is residing in the kernel memory. Yes, I'm in kernel memory because the size is FF something. Before that, when we talk about the some other function is starting, for example, the K user data exported to the user mode environment should be in the user environment. See if I can find out these location again. Yes, on the top you will see that the memory address start with FF something. Whatever you find in 64-bit environment, anything, the first 4 character is 0, then you will see 7, and anything behind that is inside, even though they are all of them are F, it will be referred to the user mode. But in the kernel, it's quite different. In this example, you will see we are inside the kernel. The first 4 character is not 0, 0, 0, 0, and anything behind that is inside the kernel. Let us go back to the slide. Okay, let me share my slide first. So the slide we do have this year I add one of the tool called SSDT view. So by using SSDT view, you can find also the anti-accept connect port that I previously showed in the WinDbg. Let us go back to the now we go back to our virtual machine. I already put the SSDT view inside your system. It will scan through the SSDT table and try to locate the exact address of the function that we call the under the address we call to the anti-accept connect port. Anti-connect, no, I cannot do a search. Maybe we can anti-accept. What is the number? Last time in the, yeah, I found the number 2, anti-accept connect port. It will be residing an address of 5F and then 888 So this is the address that we are using WinDbg to locate by checking one by one through the SSDT. That is the way how the kernel finds this actual location of the function of a anti-accept connect port. Now we go back to our slide. Okay, we go back to our slide. Now we are trying to type the command that we show all the running process in my virtual machine and then try to display the most important structure, data structure called E process structure. If we provide the address, for example, I will show you the process 00, try to find the WinDbg location. We find the WinDbg offset 0 address and then provide it with the information of anti display type of eParser structure, and you can identify whether this is the actual location of the eParser structure. And then we also be able to using the PEB to find the process environmental block. Now we go back to our virtual machine. Now we are inside the virtual machine. Let me try to type the exclamation mark process 00, which is the basically the information, no export. Okay, typo exclamation mark process 00. My keyboard out sometimes doesn't work. So it will require you to some time. Let me pause the video recording. Okay, the bang process 00 finish, and you will find that we'll be able to find the WinDbg residing inside the kernel area with the offset address this right here. Now let me try to type display E process structure. If we type this, you only have the structure. You don't have the pointing to the right location of the memory location that contain the eProcess structure. That means the process information. So now, because I already copied the entry point of the eProcess structure of WinDbg, I need to go back. Sorry, you need to be patient. Here, we need to copy this one. Control C. And then Control V. Now you will see the content of the eProcess structure. A couple of locations I want to show you. One thing you need to be aware of. The first item is called the exit time. The process is still running, so the exit time should be 0. I must miss the location. Let me try to go that again. Help me if you find it. The exit time is 0. Then the start time must be different, but between the start time, I will be able to find the program name. The program is called WinDbg. In the kernel, we call this structure. In the eProcessor structure, we call the image file name at the offset of 450, counting from the actual address in or the logical address of the eProcessor structure lies in the kernel of my running version. So other than that, we may be able to find the starting time of the WinDbg. And also the PEB is right here. If you click here, anything that with underscore in blue color, you will redirect to that location. But before we go there, we find, and I want to check the creation time. Okay, we have the creation time at the offset of 308. 308. So what is the actual time? I can use the format command in the WinDbg. It will tell you that I captured this on September 12th, almost 3 o'clock. Now, the time I record, but not the time I kickstart the WinDbg. So what if we terminate this process? Yeah, if that is the case, I think in the class, either me or Paul will show you turn on the notepad, you will using a notepad example, and then shut down the notepad, and you will be able to find this information again, even though the data structure, sometimes you terminate the process, the data structure still lies in that particular area. Okay, but my recording right here will not demonstrate this part, or maybe you can try at home by your own self. Now we go back to this slide. Okay, this year I will add up another part we call the select my parent, another tool that is created by Peter Stevens. For example, if I want to start the notepad, but I want notepad to be start behind under the control of the ELSA process, for example. So let me go to the virtual machine, and then I can show you the command. Okay, we are in the kernel, I mean the virtual machine right now. I don't need this SSDT view, but I need to open a command prompt, or maybe you can open a PowerShell, depends on your preference. So I need to find the tool called select my parent, lies in tool, the behavior tool, and then we type the select my parent, and then go to the release. And you will find the select my parent .exe. So how can I start the notepad under the ELSA process? So I need to turn on the process hacker so that you can see what's going on and how it's going to be working like this. Now we are under the command prompt. So how about we type the select my parent, and then I need to find the notepad. It's supposed by in the system root notepad.exe. So which process I want it to be my parent? If I want my parent is under the ELSA process, I need to find ELSA process information. I mean the process information. ELSA process. I don't find the ELSA process. Yeah, it's on the which the PID process ID is 664. Now we type 664. Yeah, you see the process called notepads coming out. And if we check where is the new process, new process is 4672. Now you see notepads born under, not exactly born, but basically it's formed by the ELSA process under 64672. That is one of the magic example that we can manipulate. If we have sufficient permission of the machine, we can manipulate some process even in the user mode. Now we go back to the slide, and I do have limited time today to do the demonstration. So I will capture another video so that you can follow my demonstration uh, to do the lab at home. If the Windows internal class is not successfully present everything to you in the real-time lecture.